Welcome to this advanced tutorial on Lexical Scope. Today we'll explore how inner functions can access variables from their outer functions. By the end, you'll understand how scope chains work, see practical examples, learn common mistakes, and master real-world applications. Lexical scope is a fundamental JavaScript concept. It means that variable accessibility is determined by where functions are declared, not where they're called. This creates what we call a scope chain, where inner functions can access variables from their outer functions. The scope chain is what makes this work. When JavaScript needs a variable, it first looks in the local scope, then the outer function's scope, and finally the global scope. This is called variable lookup. And if an inner function has a variable with the same name as an outer one, it shadows the outer variable. Let's look at this code. We have an outer function with a variable called outer_var. Inside it, we define an inner function. Notice how the inner function can access outer_var even though it's declared in the outer function. This is the core concept of lexical scope. Here's a more complete example. We have a global variable, an outer variable, and an inner variable. The inner function can access all three through the scope chain. First it looks in its own scope, then the outer function's scope, and finally global scope. Here's an important concept called variable shadowing. We have three variables all named x. The inner x shadows the outer x, which shadows the global x. When we log x in the inner function, we get inner, because that's the first x JavaScript finds in the scope chain. This is a practical example of lexical scope in action. We create a counter function that returns another function. Notice how the inner function maintains access to count even after the outer function has finished executing. This is called a closure. Here's another closure example. The createMultiplier function takes a parameter and returns a function that uses that parameter. Notice how double and triple remember their respective multipliers. This shows how closures can remember parameters. This is a classic example of the module pattern. We use an IIFE to create private state and expose public methods. The count variable is private because it's only accessible through the returned object's methods. Let's see how this works in a real application. We have a function that sets up click handlers for buttons. Notice how each handler remembers its index through closure. This is why we use let instead of var in the loop. Here's an important comparison. On the left, we use var which doesn't create block scope. On the right, we use let which does. This is why we get different results in our loop examples. Let creates a new binding for each iteration. Here's a common mistake. We create an array of functions in a loop using var. Notice how all functions share the same I variable because var is function scoped. This is why we get myValue 3 for all functions. Here's the fixed version. By using let instead of var, we create a new I for each iteration. Now each function remembers its own value. This is why let is preferred in loops. Here are some best practices to remember. First, use const by default and let only when you need reassignment. Second, avoid var in modern JavaScript. Third, understand that closures can affect memory. Fourth, be careful with loops and closures. And fifth, use IIFEs for private state when needed. For an advanced tip, let's look at memoization. This pattern uses closures to cache function results. The memoize function returns a new function that remembers previous results. This is a powerful technique for optimizing expensive computations. To summarize, lexical scope determines variable accessibility, inner functions can access outer variables, closures are powerful but need careful handling, and common mistakes include using var in loops and forgetting about scope chains. If you found this helpful, please like and subscribe for more advanced JavaScript content.